we're gonna have no working session on the Discord of Buildspace. And they're gonna be, I think it's gonna be 8:30 p.m. my time. Now it's 8 p.m. And I'm gonna stay for half an hour, I think. I'm just gonna stay 1 hour here. Because it's already late where I'm at, so they will start half an hour from now and go for about 1 hour, I think. So I'm gonna stay about an hour here. And they added this button to see, so we can see how many people are on each step. There's one tomorrow as well. I think these ones are the best for me in the morning. Set up a client. It's time to start working on a website or contract space people. I think I read this before. You didn't watch the video. It's on a different browser. Yeah, it's on the brave browser. Just gonna read it through, I'm not gonna do them. Go ahead and close the terminal with your local blockchain network running, which is where you ran attacks highly have node. Need it anymore. We mainly just want to show you how the plan works locally. Now we're going to be doing the real deal, deploying the actual blockchain. Go ahead and make an account with Alchemy. Interesting. This is an Ethereum like that. All the functionality of a node, including JSON, RPC support, but with supercharged reliability. Data correctness and scalability needed to run world-class applications on the blockchain. Sorry for having you make so many accounts, but this ecosystem is complex and we want to take advantage of the awesome tools out there. What Alchemy does is it gives us a simple way to deploy to the real Ethereum blockchain. Transactions. So when we want to perform an action on the Ethereum blockchain, we call it a transaction. For example, sending someone Ethereum is a transaction, and something that updates a variable in our contract is also considered a transaction. So when we call wave and it does total waves plus one, that's a transaction. Defining a smart contract is also a transaction. Every blockchain has no owner. It's just a bunch of computers around the world run by miners that have a copy of the blockchain. When we deploy our contract, we need to tell all those miners, say, this is a new smart contract, these are my smart contract to the blockchain, and then tell everyone else about it as well. This is where Alchemy comes in. Alchemy essentially helps us broadcast our contract creation transactions so that it can be picked up by miners as quickly as possible. Once the transaction is mined, it is then broadcasted to the blockchain as a legit transaction. From there, everyone updates their copy of the blockchain. This is complicated, and don't worry if you don't fully understand it. As you write more code and actually build this app, it will naturally make more sense. Make an account with Alchemy here and then check out my video below to learn how to get your APEC before our testnet. I'm not going to be the point to determine it. I think it's self-explanatory. I'm doing the fake net so you don't spend money when you're just testing and building stuff. Yeah, it's some fake money. There are a few testnets out there, and the one we'll be using is called Linkby. In order to get fake Ethereum, we have to ask the network for some. This fake Ethereum will only work on this specific testnet. We have some fake Ethereum for trying to faucet here. The easiest way to do this is to make a tweet with your public Linkby wallet address, which you can find on my MetaMask, and then input that directly URL into the input box. Why did they make you do this? Take you guys and post your ideas in first chat. You see anything? Maybe? To prevent malicious actors from exhausting all available funds or accumulating them. Enter to mount long-running spam attacks. Requests are tied to common to third-party social network accounts. That's fine. Anyone having a Twitter or Facebook account may request funds within the permitted limits. But can't just someone just create a fake Twitter account then? If you understand. On the faucet, I don't know how to say this, but working decently well. Over here, connect to your wallet, then have to faucet. Request some money. If this doesn't work, then just ask me for some. As mentioned in the update. Well, root directory of my smart contract project. Oh, I guess it's on after you install this. The MetaMask can connect it to this. No. Grab your API URL from the Alchemy dashboard and paste that in. And also, you put this code on the hardhat config.js file. It's probably a file on the repo website, because I don't have one here. Oh no, here it is. Oh, this part. Here, I'm not sure what it is, but I'm not gonna do it. So just gonna copy. You would take this from the MetaMask, the private key. Private key is the one that you keep to yourself, and the public key is the one that it is used to recognize your wallet. And use you would put the link, I think, to your API on the after you register on this website, which is Ethereum API. There's a mistake here. Not that it's I did the wrong way. Grab your API URL from the Alchemy dashboard and paste that in. Then you need your private read by key and triple with headers. You can grab from MetaMask and paste that in there as well. I'll make a quick video covering this below. Why do you need to use your private key? Because in order to perform a transaction like the final contract, you need to log into the blockchain. And your username is your public address, and your password is your private key. It's kind of like logging into this cloud service. Once you've got your config set up, you're set to deploy with the deploy script we wrote earlier. Run this command from the root directory of Pineway portal. Notice all we do is change it from localhost to root because you're deploying from to a different place, I guess. Copy that address to the deploy contract in the last line, save it somewhere. Because this is gonna be the address for a contract, I think. You just deploy your contract. You can actually take that address and then paste it into Etherscan. Etherscan is a place that just shows us the state of the blockchain, help us see where our transaction is at. You should see your transaction here. It take a minute, a few minutes to show. It may take a minute to show. How they will make money from this on the future. Or if that's even their goal or doing. you have something else in mind. So in order for our website to talk to the blockchain, we need to somehow connect our wallet to it. Once we connect our wallet to our website will have permissions to call smart contracts on our behalf. Remember, it's just like authenticating into our website. Head over Replit and go to app.js under your source. This is where we'll be doing all our work. If you're logged into MetaMask, it will automatically inject a special object named Ethereum into our window. Let's check if we have that first. So this is the step from Replit that it does automatically. So this is an error message if this constant doesn't exist, which is refer to the window, then it displays a message or unreturned. Otherwise, you have the Ethereum object and it will show up Ethereum, which is the window. This runs our function in the page loads. First, make sure we have access to the react.use effect. And then this is the HTML part that is going to render. See if we can access the user's account. So when you run this, you should see that line where the Ethereum object printed the console of the website when you go to inspect it. Next, we need to actually check if we are authorized to actually access the user's wallet. Once we have access to this, we can call our smart contract. Basically, MetaMask doesn't just give our wallet credentials to every website we go to. It only gives it to websites we authorize. Again, it's just like logging. But what we're doing here is checking if we are logged in. Check out the code below. This is the code from before. Slide 3. This is Ethereum.request to request account. So we use that special method, Ethereum's accounts, to see if we're authorized to access any of the accounts in the user's wallet. The thing to keep in mind is that the user could have multiple accounts in their wallet. In this case, we just grab the first one. When you run the above code, the console log, console.log, that prints should be no authorized account found. Why? Because we never explicitly told MetaMask, hey, MetaMask, please give this website access to my wallet. We need to create a connect wallet button. World of Web3, connecting your wallet is literally a login button for your use. Check it out. So connecting wallet is the login button. It's pretty much the same thing from before. Maybe there's some stuff added here. Is use effect. Mm. Now const connect wallet. These request accounts. Yeah. Code is getting a little long here, but you can see how short our connect wallet function is. In this case, I use the Ethereum request accounts function because I'm literally asking MetaMask to give me access to the user's wallet. 967, I also added a button for this line. So we can call our connect wallet function. You'll notice I only show this button if we don't have cure account, which is current account. If we already have cure account, then that means we already have access to an authorized account in the user's wallet. Then on click, it activates this function, connect wallet, which is specified here. If we don't have Ethereum, it's gonna show up an alert, get MetaMask. And if we have Ethereum, which is the window, I'm gonna use this method to request account. I don't think I'm gonna answer this, to be honest. Yeah, they are on the co-work slash thing. See what people are working on. Um, this is the just Farzan speaking, one of the team members for the project. What does it mean to learn alongside other? You feel like you're building alongside other just Buildspace. Fine, learn. Or when? Mm, I don't think I'm learning alongside others because it's pretty much everyone doing their own thing, but I'm not sure if it would be better if everyone. It's kind of hard for everyone to do the thing together when it's something online like this. Maybe this it's but I don't think that's a bad thing. I'm pretty sure you can connect with people in the Discord in case you want to do it together, but yeah. This returns the total number of waves. That's the address of the contract when it, after deploying to the testnet. Think by it's an API. Make sure that I mentioned how when you compile a contract, it creates a bunch of files for you under artifacts. When you compile, an API is one of those files. Check out my video below. I'll go over this and show you how to add it to your project. Once you add that file and click the leave button, you'll be officially reading data from your contract and the blockchain to your web client. In the code for writing data to our contract isn't super different from reading data. The main difference is that when we want to write new data to our contract, we need to notify the miners so that the transaction can be mined. When we read data, we don't need to do this. Reads are free because all we are doing is reading from the blockchain, not changing it. Here is the code to read. Provider.get signer. Just this stuff. I did it earlier. At least some parts of it. These ones I didn't do. The consigner, const provider, and also const wave portal contract. What's awesome here is while the transaction is being mined, you can actually print out the transaction hash, copy paste it through Etherscan, and see it being processed in real time. When we run this, you'll see that the total wave count is increased by 1. You will also see that MetaMask pops us and asks us to pay gas, which we pay for using our fake money. I will talk about this on the live stream. There is a great article here. This is the full code of the React part. What is the ABI again? Yeah, I think I'm done for now. I'll probably hang out on the session and listen to the questions that people have, you know. But I'll close off the stream. So yeah, I'll probably stream tomorrow and finish this thing off and start the Recode Camp challenges again. I'll see you.